Welcome to Animated Maths for All, Series 2. Here we learn, grow, and excel together in mathematics. This video continues our exploration of real-world maths problems, starting with a question about water flow in a river. The students are observing the flow of water where the river meets the sea. One points out that if the rate of flow is known, the volume of water entering the sea per minute can be calculated. We are given the river's dimensions, 40 meters wide and 3 meters deep. The rate of flow is 2 kilometers per hour. The goal is to calculate the volume of water falling into the sea in 1 minute. The problem is, if the river is 3 meters deep and 40 meters wide, flowing at 2 kilometers per hour, find the volume of water that falls into the sea in a minute. Let's list the known dimensions. Depth, h, is 3 meters. Width, w, is 40 meters. And the rate of flow, which is the length, L, of the water, is 2 kilometers per hour. Since the depth and width are in meters, and we need the volume per minute, we must convert the rate of flow from kilometers per hour to meters per minute. First, convert 2 kilometers to 2,000 meters. Next, convert 1 hour to 60 minutes. The rate of flow is 2,000 meters divided by 60 minutes, which simplifies to 100 over 3 meters per minute. The volume of water is calculated by V equals length times width times depth. Substituting the values gives V equals 100 over 3 times 40 times 3. Canceling the 3's gives V equals 100 times 40, or 4,000 cubic meters. The final answer is that 4,000 cubic meters, or 4 million liters of water, will fall into the sea in a minute. We found the volume. Everyone celebrates the successful calculation. Math, no myth. The rate of flow in a river is typically determined by a current meter. Knowing this rate, along with the width and depth, allows you to calculate the volume of water entering the sea. Next problem. Let us carve out a cone of maximum radius from a wooden cylinder. This is a problem involving volume and geometry. The students are in a workshop, ready to start the carving. One expresses their enthusiasm for carving solids from a solid. Monko, I carved out a cone of the same radius as the cylinder. Great job! You carved out the maximum size cone. Now we can find the ratio of the volume of the remaining wood and the volume of the cone. Step 1. Identify the dimensions. For the cone to have the greatest possible volume inside a cylinder, its base radius and height must equal the cylinder's radius and height. Step 2. Calculate the volumes. The volume of the cylinder is pi r squared h. The volume of the remaining wood is the difference between the cylinder's volume and the cone's volume, which is 2/3 pi r squared h. Step 3. Determine the ratio. The ratio of the volume of the remaining wood to the volume of the cone is 2/3 pi r squared h to 1/3 pi r squared h. Simplifying the ratio, we cancel out pi r squared h from both sides, leaving 2/3 to 1/3. Multiplying by 3 gives a ratio of 2 to 1. The volume of the remaining wood is twice the volume of the carved cone. Practice makes perfect. By solving these problems, we will not lose any marks in the exam. Thank you for watching. We hope you enjoyed this animated math video. Subscribe to our channel and explore more content from AniMath International School.